All right, so welcome to Mr. Baker's House of Knowledge. What do we remember from Unit 6? How well did we retain that knowledge that is so very valuable? All right, so in Unit 6, one of the things we did is we found the angle sum measure of any polygon, the sum of all of its interior angles. We knew from our work with a triangle that triangles were 180. We've worked with rectangles and squares and found out that those specifically were 360. But now we have found a way to find the measure of any sum of any interior angle of any polygon. By the way, what's the minimum amount of sides you could have for a polygon? 3, and that's called a triangle. What's the maximum amount of sides you can have?
Infinity.
Yeah, you can have as many sides as you want. The more sides you have, the closer it looks like a circle.
Sorry, do you not remember like the 14? I don't remember.
So we did have 14 gons. We did have 19 gons. But you could have an infinity-agon, which would look very much like a circle. In fact, the computer, when the computer draws a circle on your screen, or when you see circular objects on the screen, what you're really seeing, or what's really there, what the computer is really doing, is it's made a polygon of so many sides that you can't tell, you can't see the sides because they're so small. And so it just looks like a circle. Yeah, but if you zoomed in close enough on any circle that you saw on a computer, you would see that it made a side at some point.
Oh my God, that's blowing my mind.
Yeah, that's just the way you have to draw it on the computer. A computer connects lines from one point to the other.
Like, what if you zoomed in so far? It's like this little teeny tiny corner.
That's absolutely possible. Yes, ma'am. You may. So, how do we do that? Well, I like to call it the interior angle measure, or the IAM. And the IAM is always equal to the number of sides you have minus 2 times 180 degrees. So the more sides in the polygon, the bigger the sum of the interior angles. So how many sides does a heptagon have? Try again. 7. So 7 minus 2 times 180 is just like 5 times 180. 5 times 0 is 0. 5 times 8 is 40. Carry the 4. 5 times 1 is 5. Plus 4 is 9. So the IAM, or the interior angle measure of a heptagon, is going to be 900 degrees. Does that make sense? So that formula can be used to determine how many, the sum of the interior angles. If you have the sum of the interior angles of a polygon, you can decide how many sides it has by solving for n instead of solving for IM. So here's what I want you to do now. I want you to find the sum of the interior angles of a 17 gon for part A, and then for part B, I want you to, if I tell you that the interior angles are 1980, I want you to tell me how many sides it has. All right, so for part A, what I want to do is I want to use the formula IM is equal to n minus 2 times 180. And would you be surprised to know that in part B, we're going to use the same formula?
No, because we learned that last year.
Yeah, we did learn that last year. So I'm just going to copy this formula over. Everybody's favorite, the camera sound. Except this is B and not A. All right, so for part A, we're trying to find the sum of the interior angles of a 17 gon. So that's going to be 17 minus 2 times 180, which is 15. I like how you did that in your head. Times 180. And then 15 times 180 is? I got 2,700. AKA 2,700. So that's the sum of the interior angle measures. Now, on this other one, what's different about part B and part A?
You know that I gives you the interior
Right.
angle measure. you have to find the number of sides.
That's right. So we already know this. So instead of solving for I am, we're solving for n.
What?
So I'm going to substitute 1980n. And what would be the first thing you guys would do for this equation?
80 by 180.
I would divide 1980 by 180. What is that when we do that? 11. So dividing both sides by 180, you'll cancel the 180 on this side and give me 11 on the other side. And then what do we do?
Subtract 2 minus
You
180.
You add 2.
Oh, add, sorry.
So that'll be 13. So that's that. Everybody okay? Anybody get any divergent answers or insurgent answers? You like what I did there?
Yeah, so many words.
Yeah. All right. All right, so I don't know why I put this up here because I'm not going to use this information in the next problem, but it's just here. So this is also good to know. If you're having a regular figure, the interior angle is just equal to n minus 2 times 180 divided by n. And that'll give you the measure of each angle in a regular figure. So here's the formula for finding the angle of a regular figure if you know how many sides it has. Another way we can find angle figures is by adding up all the angles and setting it equal to the IM. So in this particular problem right here, if I'm trying to find the measure of angle Y in today, first of all, I need to know that that is the measure of angle Y plus all the values of the other angles. 90 plus 110 plus 120 plus 150. And that's going to equal to, that's the IM now, and that's going to equal to n minus 2 times 180. So n minus 2 times 180, in this case, n is 5. So 5 minus 2 times 180 is 540. And then if I add up all of these numbers, I get 470. And so the measure of angle Y plus 470 equals 540. So I just subtract 470 from both sides, and the measure of angle Y is equal to 70. So you can find the angle, the missing angle, by using the formula. If I told you it was a regular figure and I asked you to find the angle, then you'd use, I lost my pointer. Whoa, I lost everything. You would use that thing up at the top. You'd use this formula up here. All right, so there's a little yellow box there. What do you think that means?
Oh, then there's another problem under.
Yep. And so here's what I want you to do. I want you to find the measure of angle G in this figure right here. Hey, boo boo. Ready, go. So the answer is 102. All right. The sum of the measures of the exterior angles, you might remember, is always 360 degrees. No matter what, your exterior angles are going to be a big bad 360. So if I tell you you have a regular figure that has 8 sides, how would you find the measure of the exterior angles? Yes, Taylor?
You do 360 divided by 8.
That's right. So to find the measure of each individual exterior angle, you take the sum of the exterior angles, which is always 360, and divide it by the number of angles you have. So for an 8-sided figure, you'll have 8 individual exterior angles. So that's going to come out to be what, 45?
I don't think so.
All right. 360 divided by 8 is 45.
Taylor.
I just said that.
Taylor just likes to argue. All right. For your challenge, I want you to find the measure of an exterior angle of a regular nonogon. Nonogon.
Was that 9?
So the answer to this one is 40. All right. You might remember that we talked about 6 different properties of a parallelogram. You need to know these. So if you have forgotten these, this is a great time to review. You will see them again. Heck, it might be the bell ringer tomorrow. So properties of parallelograms are the definition. Both pairs of opposite sides are parallel. That's what makes a parallelogram a parallelogram. That's its definition. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One pair of opposite sides is both parallel and congruent. The diagonals bisect each other, and consecutive angles are supplementary. Does anybody need me to go into more detail about what each of those things means? Because I would be happy to do
Wait,
so.
can you go back over the parallelogram? What did you say about that? Like the definition of it.
So both pairs of opposite sides are parallel.
Don't do that. Never mind.
So this is the definition of the parallelogram. Statement 1 is its definition.
Could statement 5?
So if you have that to exist, you can say that the thing is a parallelogram, but you wouldn't use definition of parallelogram as the reason. You would use diagonals bisect each other as the reason. The only time you would use definition of a parallelogram as a reason is if it qualified for statement 1. And you could use statement 1 or you could use definition, and that would be acceptable. Any questions about these properties? All right, so not only did we have parallelograms, but we started talking about other things. We started talking about a rhombus. We started talking about a rectangle. And we started talking about square. So a rhombus is a parallelogram in which all the sides are the same. A rectangle is a parallelogram in which all the angles are the same, which using that formula, parallelogram has 4 sides. If all the angles are the same, then 360 divided by 4 would make each of them 90. And a square is both a rhombus and a rectangle at the same time, where all the angles and all the sides are the same. Those are called regular figures. We just happen to have a special name for a regular 4-sided figure. It's a square. So here's a little diagram of what is a subset of what. And these are important. And the reason these are important is because you need to know that if I tell you something is a rhombus, a rectangle, or a square, it inherits all the properties of a parallelogram as well. In fact, when I teach computer science, we do things where we make classes, and certain classes inherit from other classes, and they call it inheritance, when something is a subset of something else. So you're actually learning a little bit of computer science right here and understanding this diagram.
Isn't it also biology?
Yep. So it's basically anything where something is a subset of something else. So if I'm a square, I'm a subset of rhombus, so anything that's true about a rhombus is also true about a square. Anything that's true about a rectangle is true about a square. So in a parallelogram, I know that opposite sides are parallel and opposite sides are congruent. That's true for a rectangle and a square and a rhombus as well. That's why it's important to know the subsets, because that means this figure has all of those properties as well. Then after we talked about rhombuses and rectangles, we learned some special cases about them. And this is where first period was a little weak, so maybe you guys will need to go and bone up on this stuff too. Look at it tonight, kind of review it, because it's important. It definitely is going to show up on the test next week. So a parallelogram that's a rhombus will have perpendicular bisectors that are diagonals that are perpendicular bisectors. And a parallelogram that's a rhombus will have diagonals that bisect the angles. So in a rhombus, if I draw a diagonal, it bisects the corner it comes out of. Both corners, actually. Does anybody need me to go into more detail about that? Or is that kind of, oh yeah, I remember that. Maddie, you remember that? Okay. And then for a rectangle, so a rhombus had 2 things. Perpendicular bisectors for the diagonals, and the diagonals are angle bisectors of the corners or the vertexes. And then in a rectangle, the diagonals ended up being congruent. So perpendicular here, congruent here, but both of them are bisectors because they're a parallelogram, and in a parallelogram, diagonals bisect. So you got to kind of remember everything all together. Trust me, you need to go home and brush up on this. All right, why? Because I want you to be able to tell me what type of figure we got. So what type of figure does one look like? It can either be a rhombus, a rectangle, or a square, because I'm already telling you it's a parallelogram. Why do you think it's a square? Because it looks like one? It's got two congruent sides, but they're not opposite.
90-degree angle.
It's got one 90-degree angle. So is a square a four-sided figure with one 90-degree angle?
It's at least a rectangle.
Okay, so we know it's a parallelogram. We know it's at least a parallelogram. What do we know about parallelograms? Tell me some facts about parallelograms.
That each sides are congruent to the
So if each side's congruent, I'll put a 1 marquee there and a 1 marquee there. Now it's at least a rhombus.
Well, they're also congruent, so wouldn't that make...
I marked them congruent.
I know, so wouldn't it make the angles congruent?
Nope. Just because two lines are congruent doesn't mean their angles are congruent. For example, those two angles are definitely not congruent. All right. What else do we know about parallelograms?
Well, they're parallel, like the opposite sides are parallel.
Yeah, I already got that marked. What else do we know? Give me something new.
They equal 360.
Yeah, give me something new.
The diagonals bisect.
Okay, give me something else.
Opposite angles are 90 degrees.
There we go. Opposite angles are congruent. So that means that angle and that angle are both 90. What else?
Oh, they're also supplementary.
What's supplementary?
Corresponding angles are
Consecutive.
I was getting
So that'll be 90 and that'll be... Oh, now we have a square because it's equal angular and equilateral. So that's a square. All right, tell me about number 2. It's a parallelogram. Why? How do you know it's not a square?
We don't know.
The squares have 90 degrees.
Well, how do you know that this doesn't have 90 degrees?
That's one third.
All right. So, yeah, opposite angles are congruent, consecutive angles. So, yeah, it's not going to be a square. So, it's not going to be a rectangle. So, it has to be a rhombus because all the sides are the same. All right. What are the measures of the numbered angles in this rhombus? So, if I tell you a rhombus, I'm also telling you it's a parallelogram. Tell me what the numbered angles are. What's the measure of angle 3? 40. So you're already wrong. Because what do you know about rhombuses?
It's 50.
Right. Why?
Bisects.
Right. Because in a rhombus, a diagonal bisects. What else about the diagonals in a rhombus?
They're congruent.
No, that's a
Opposite
rectangle.
ones are
90 degrees.
They're perpendicular. So that makes 92 what? I mean, that makes measure 2 what? 90. And then if this is 90, this will be 90. If that's 90 and that's 50, what's that?
90 and 50 is 140.
Try again. No, it's, yeah, you're right.
You're right. 40.
Right. Because 40 plus 50 plus 90 is 180. And we know that the sum of the interior angles of a triangle is 180. So see, all those rules that I showed you about the rhombus look pretty easy until we actually start trying to apply them. So you need to practice the application instead of just looking at the rules. You with me on that? Practice, practice, practice. Right, Maddie? Mm-hmm. You still awake? How many fingers am I holding up? You're fine. All right, so algebra, JKLM is a rectangle. If JL, how would I know that this would be a diagonal of the rectangle? How do you do know?
Draw out.
Yeah, if you draw it out, then the corners are consecutive. So the two letters that aren't next to each other are going to form diagonals. So JL is a diagonal, MK is a diagonal.
They're congruent to each other.
And they're congruent to each other because it's a rectangle. So that means that 4x minus 12 is equal to what?
4x.
Well, yeah. Definitely 4x minus 12 is equal to 4x minus 12. How about this? How about this equation to start out with? I agree with you. X does equal 4, but let's go in order so that you can show the steps.
Subtract 4x.
So if I subtract 4x from both sides, I get this doohickey. And then if I divide by negative 3, I get that doohickey.
Oh, okay. He's not subtracting it.
So you don't think x minus 4x is negative 3x?
You said minus 12. I don't know, but I feel like if it
Well, I just brought down the minus 12.
Oh.
And then it's positive because when you divide a negative by a negative, you get positive. No.
That's what it looked like.
Where does it look like I subtracted 12?
It's just like when you were doing it, you were saying it, and then you did that.
Okay. So we agree that x is equal to 4, right?
Yes.
So what are the lengths of the two diagonals then?
4 and 4.
Yeah. If one of the diagonals is x and x is equal to 4, then the diagonal length is just 4. And the other diagonal will be the same. In fact, you could plug it in. 4 times 4 is 16. 16 minus 12? 4. Amazing. All right, work these 3 multiple choice problems and see how you come out when you get done. Compare your answers with your partner. All right, so what's the answer to number 32?
I didn't get that far.
Why B? Because what?
Because in a rhombus, the diagonals bisect each other, and so once you know it's
So diagonals bisecting make it a parallelogram.
Yep, but then even more so, a rhombus. I think it's not enough information, honestly.
Well, I mean, you already gave me enough information to tell me that it was a parallelogram. However, the diagonals don't bisect each other. What do the diagonals bisect?
Oh, the opposite angle.
So that does make it a rhombus.
Do it.
All right. Number 34, what is it?
Oh, it's 360.
Why 360?
All
Because that's always exterior. So number 35 is the important one. What's number 35?
Yeah, I don't think they're gonna look at it.
So what if I told you I was giving you a class test grade based on the answer to this question?
I would start working it out.
Should have already worked it out. So I'll give you a minute and a half. Ready, go.
No, it's.
Here we go.
60.
Already with my calculator.
But isn't it always?
Oh, I have the sheet.
Yeah, that's number 34. We've moved
I think
on.
this is wrong.
Oh, sorry. Oh, I'm good at these.
Okay, Mr. Baker, this is just not my day.
All right, so what answers do we want to throw out there?
Okay, I'm not done it yet.
I need some too.
Stop.
I gave you time.
Negative 4.7, Mr. Baker.
All right, negative 4.7. Does anybody get something different?
I got negative.
I have to go.
Negative 3. Anybody get something different? So I tell you what, I'll go ahead and any of the answers that we put up here, up to a maximum of 10, if any one of them is right, I'll give the class 100. Otherwise, the class gets a 0.
4, negative 7.
4, 7.
Negative 4, 3.5.
4, negative 7.
Wait, let me just start throwing numbers out.
I mean, you can do that, and out of all the numbers in existence, you'll have a chance of getting it right. It might be better to work it correctly, though.
You didn't give me enough time.
I gave you plenty of time.
No.
Can we use a
You know
computer?
today is not my day.
I think we should use.
I need.
I don't
It's
definitely -4.
It's negative 4. Negative 4, negative 7. No,
We haven't tried
-4
and 3 yet. We haven't tried -4 and 3 yet.
Negative 4 and 3. We have to try negative 4 and 3.
Oh.
So that's the one we haven't done yet.
Okay, for some reason I got X as -9.
Okay. Where is that?
But I
Let's
think
go ahead
I'm
and throw
on
it
to
out
the-
there. Alright. Keep going, Taylor.
Okay, what's on here? 4 is equal to
Mr. Baker, what time did we determine this one? 10:01. 10:01. Yeah. No, we have them. Oh, yeah. That's second.
Negative 4, negative 3.
It's -2 for Y. Yep,
Oh, God. Negative 4, negative 3. That's not right.
I think it is.
All right, I think I'm done. Let's go ahead and work it. So the midpoint formula is found by an x-coordinate midpoint and a y-coordinate midpoint. And each of those midpoints is found by adding the two x values and dividing by 2, or adding the two y values and dividing by 2. So in this case, we start out with a midpoint, so we're not discovering what mx and my are. We've already got them because we've got the midpoint. So I'm going to put a -1 here, and I'm going to put a 4 here. I have a feeling you're wanting to revise your answer at this point.
No, that's what I did.
No, that's
right.
what I said. I said it was
right.
a weird one, and no,
Taylor for the win.
So x plus the x coordinate is -7. I'm going to just write x minus 7. Everybody okay with that?
Yes.
Because that just looks awkward. And then I'll multiply both sides by 2. So that's -2. And then I'll add 7 to both sides. So 7 plus -2 is a +5.
Oh, well, I did
I just
7.
I don't see any answer here with a +5.
And there's only 8 up there. You said a 10.
So yeah, but we ran out of time. So that's a 0 out of 100.
Wait, I'm so confused what you did.
And then y1 plus 10 divided by 2. And I'll multiply both sides by 2. So that's going to be y1 plus 10. And I'll subtract 2. And 8 minus 10 is -2. Wait, didn't somebody get -2 as one of the, yeah, look at that.
I told you.
So yeah, I should give you a 50 out of 100 because at least you got one of the coordinates right.
Good job, Taylor.
I said 5 right before you found it out. So.
Thank you, Taylor.
You're welcome.
So we've done this a lot. All right, so the correct answer is 5 -2 for 35. So what I want you to do, and I want you to take this seriously. Tonight we've got some review problems on a worksheet that I've posted on Edmodo. I want you to do your worksheet. Come back tomorrow ready to go over them. This lesson will be posted on Edmodo. If you need some review from some of the stuff we talked about in class. And as normal,